Alrighty, so new situation here. We got Vanilla Ice has a flagpole in the front yard. It's Palm Beach flip. However, it needs to be restrung. I actually faced a similar problem at the River House. I had a flagpole, needed to be restrung. Didn't have anything up there so I could hang my American flag. This is important, right? I didn't know how much rope to buy, but I could figure it out. So he doesn't know how tall it is, but he is 30 feet away from it while laying on the ground, and he looks up to the top of it at a 50-degree angle. So how tall is the flagpole? And then I think we should also add in there, let's see here, how about how much rope should he buy? Okay, those are two great questions, and they may or may not have the same answer. So let's go for it. Well, if I got a flagpole, right, it's just a straight up and down thing, and he is laying down, right, let's draw a little stick figure, yay. He's laying down and looking up here. He's 30 feet away, right? And this is a 50-degree angle. We put down that he was laying down, so we didn't have to account for like his height when figuring this out, because it can get a little bit more complicated. But we can figure out how tall the flagpole is using some trig. Now, this is a little different than yesterday. We're actually given the angle rather than finding the angle. So as a quick recap, we know that sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to the adjacent over the hypotenuse. And then tangent of an angle is equal to the opposite over the adjacent. Okay? So we got those three main trig functions. Since we have an angle, we're using regular trig, not inverse trig. So what information do I have? Well, let's see here. I've got across from the 50, that's my opposite side. And next to the 50, that's my adjacent side. We've been dealing a lot with tangent lately. It is the most common. I promise we will get into some other ones as well, right? Sine and cosine as well. But tangent's super applicable in the construction world. Okay, so let's set something up. Let's see here. I've got my tangent. Since I know that's my function, what's my angle? 50 degrees. So tangent of 50 is equal to, I don't know my opposite, but I know my adjacent is 30. Well, you can actually calculate the tangent of 50 in your calculator. If you were to type that in, tangent of 50, you're just going to get a number, about 1.19. Don't round it. We don't round until the end. How would I solve for x? Well, over here I am dividing by 30, right? How do I undo dividing by 30? I would multiply by 30 on each side. So I could type into my calculator what I have right here, 30 times tangent of 50. Or if I've already typed in tangent of 50, I'm just going to multiply that already in my calculator, and I'm going to get x equals 35.75 feet. So that's how tall the flagpole is. Right? That's our first part there. That's how tall the flagpole is. But how much rope should he buy? What do we think? Well, if you ever strung a strung a flagpole, it basically goes up to a pulley, comes back down to like a hook where you can like connect it, and then it comes back up to that pulley. So that way you can just pull it up and down by it going kind of around in a circle, and then the flag is attached at one spot. So really we need like a little more than double the amount of rope. So if I double that, I'm at like 71.5 feet. Why don't we just say we're going to need about maybe 75 feet. I think that'd be pretty safe. If we found a 75-foot roll of rope, we'd be able to tie a knot, get it all good. Awesome stuff. Cool. Dope. Oh my goodness, Vanilla Ice is back, and he has expanded his home rehab projects to retirement homes in Palm Beach. Quite the lucrative idea, if you will, for the Florida community. All right, but he needs to build some handicap accessible ramps around the premises. All ramps must be at a 10-degree incline to meet code. One ramp's going to be 3 feet high, and he has 20 feet of space to build it. Will he have enough room? If so, what's the length of the actual ramp so he knows how much plywood to buy? So he's going to sheet this thing as well. Maybe it's 4 foot wide, maybe it's 8 foot wide, but at least we can give him a length of the ramp. And then, from there, we can figure other things out. But first, let's see if we can actually even build it. Okay, so our wheelchair ramp, our handicap accessible wheelchair ramp is going to look something like this. with my incline being 10 degrees, right? And it's got to be 3 feet high. This is the information I know. And we have 20 feet of space to build it. Do we have enough room? So really we're looking at this horizontal dimension. Do I have enough? Well, across from the angle, it's my opposite. Next to the angle is my adjacent. Let's not forget that this guy's a right angle, right? So again, I'm using opposite adjacent. That is my tangent function. So tangent of my degree is equal to my opposite over my adjacent. Oh no, this one's kind of a pain in the butt to solve. Okay, got to get a little creative with algebra. Well, I can, the thing about tangent of 10 is it's just a decimal. It's like 0.176, blah, 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 blah. It's just a decimal, whatever. So it's just a number. That's all we're dealing with. So let's think algebraically how we'd solve this if that were just a number. Well, to get rid of the x, I'm going to multiply by x. Oops, changed colors there on accident. And then, let me just erase this guy, rewrite it. Okay, so x. And then, if I want to get x alone, so I've got x times the tangent of 10 is equal to 3. I would just divide by tangent of 10, because that's just a decimal, right? We're going to have to practice this in class, I think, because this can get kind of confusing when you start seeing like almost like partial words in these problems. Okay, so, cancel. X is equal to, if I type in 3 divided by tangent of 10 into my calculator, 3 divided by tangent of 10, that's going to give me 17.01 feet, so roughly 17 feet. Do I have enough room? Heck yes, I do. So we are good. Yay, yes we do. But then it asks, what's the length of the actual ramp? Meaning, what's that length? Let's call that y. That's called my hypotenuse, right? Hypotenuse. Well, let's use what we were given. We're given 10 degrees, we're given the 3-foot height. Because if I start using stuff that I found, one, it's rounded at this point. Like if I use the 17 feet, it's been rounded. And two, what if I made a mistake figuring that out? So let's use what's given. Okay, although there are other ways of doing this than what I'm about to do, I like to use what's given. So, in red, we've got hypotenuse, and then we've got our opposite side. Opposite hypotenuse, what goes with that? If you guess sine, you are correct. So sine of my angle is equal to my opposite over my hypotenuse. Oh my goodness, it's the same kind of algebraic situation as before. Maybe you're remembering this now. We multiply by y, then divide by the trig function. So in your calculator, you're really typing in 3 divided by sine of 10, and that'll give you your angle. Y equals, so if I do 3 divided by sine of 10, I'm going to get 17.3 roughly, 17.276. Heck yeah. So that's the length of the ramp. That's what he needs to account for when purchasing plywood. Okay, now if he has a width, he can calculate the area and then really get going on how many sheets of plywood he might need or whatever material he's planning to use to sheet this. Okay, but we got that length, we got that dimension based off of this information. Awesome. YOLO. America. All right, we got one more problem here. We've got Drake, and he's adding a zip line to his house, which is something I've always wanted to do since I was a young lad. He came into 300 feet of wire, right? Maybe a buddy just gave it to me like, hey, bro, I got 300 feet of wire. You want to make a zip line? And he's like, heck yes, I do. Now, he wants the zip line to be at a 20-degree angle descent. Okay, so that's his plan there. And he's planning to anchor it at the end of the line to a 10-foot high post that's out in the middle of his lake. Right, so that way you can jump off, cannonball, do backflip into the lake. It's going to be great. How high up should he mount the start of the zip line? Okay, so let's say we've got this this lake here. We'll make that blue, like because it's a lake. Yay, water. Okay, and then we've got a 10-foot high post, right? So that's 10 feet. He's going to anchor the zip line to it. Let's say we've got his house. Let's make this all like about the same level. We're going to go with that. So his house is on the ground. Right, I don't know how tall it is, but we'll find out. Okay, and that's a little house there. We got a little front door, right? Maybe a window or two. Whee! Drake's house. Okay. So he's got a 300-foot zip line, and it's going at a 20-degree angle. So it's going to look something like that, right? I don't know how high up it's going to be, But this is what we're trying to find. We don't know what that's going to be right there, right? That's how high up we want it. That's our end goal. How high up off the ground should he mount it? I know this is 300 feet. Okay. And I got a 20-degree angle of descent. Now the nice thing about an angle of descent is it's actually the same as the angle of ascent. So if I were to create a right triangle, I can make this 20 degrees, right? Because what's actually happening is if it's a 20-degree angle of descent, that was supposed to be a dashed line. If you were to draw in a line that's parallel to the ground, this angle right here is the same as this angle right here. Okay? That's fancy math right there. So that angle of descent, which is 20, is the same as the angle of ascent. Okay. So I've got 20 degrees down there. I've got 300 for my hypotenuse, right? The one that's across from the right angle. That's my hypotenuse right there. Heck yeah, it is. Hypotenuse. Hype. I'm getting hyped just thinking about this problem. And I want to figure out what this is over here. I'm actually going to call this y right now because in the context of the triangle, we can't really find x yet because x is more than just that side of the triangle. Okay. But let's think ahead a little bit. If I find that y value, what could I do to get my x value? What's this right here? That was absolutely terrible. There we go. Well, that's 10 feet, right? Because we've got this over here. This is 10 feet, so that's got to be 10 feet. It's like a rectangle, right? We're going to talk more about quadrilaterals later, but opposite sides, it's going to be the same right there. Okay, cool. Well, let's figure out what our y value is, shall we? Okay, that y value, that looks like that's opposite from our angle that we want, right? Opposite OPP, opposite. I've got my hypotenuse, so if I want my opposite, I've got my hypotenuse in an angle. Oh man, we're using sine. Sine is opposite over hypotenuse. So sine of my angle equals the opposite over my hypotenuse. Ooh, this one's much better than some of the other ones we've had. All I got to do to solve this is multiply by 300 on each side times 300. I would write next to it, but I can't because I have other like task bars next to this, and I can't write over there. So I put the 300 up there. Yay! Okay. So when I type that in my calculator, 300 times sine of 20, that's going to equal my y. So in my handy-dandy TI 84 calculator or TI 83 calculator, all of which are not affiliated with TI the wrapper, although I bet you he wants to be, I'm going to type in 300 times sine of 20, and what do we find here? Looks like it is 102. Oh, okay. This is quite the deal here. I'm hoping he has some kind of a giant mansion or something like that, because this is 102.6 plus the 10 feet that it's already going to be off the ground. We're looking at a final answer of 112.6 feet off the ground. So either we're hoping that his house is built on a cliff high up, and or he's got some kind of like 12-story house that he's planning on mounting this awesome zip line to. You know what I'm saying? That'd be pretty awesome, though. Excellent. All right. That was fun. I can't wait to get invited to Drake's house for his awesome new zip line and giant mansion that is over 112 feet tall, or possibly just built on an awesome cliff. All right. America.